Hi, I'm Yusuf. In this video, I'll introduce you to Anemos, an open-source single-binary CLI tool that allows you to use JavaScript and TypeScript to manage your Kubernetes manifests. You can download the Anemos binary for your OS from GitHub and add it to your path to get started. Let's start by creating a new Anemos project using the Anemos new command. This command will create a bunch of files. The essential one here is the index.js file. The others are used for package management, which we will cover in a minute, and for a better IDE experience. Let's open and inspect the index.js file. First, we import the Anemos library, and then we create a builder, which is the main object that drives the manifest generation. The parameters for the builder are the Kubernetes version, the distribution of the target cluster such as Minikube or kubeadm, and the target environment such as development or production. These are static pieces of information that are used by Anemos packages to customize the generated manifest. In Anemos, the simplest way to generate a manifest is to add a new document to the builder. The first parameter specifies the name of the file, and the second parameter specifies the YAML manifest. You can use JavaScript template literals to pass variables to the YAML manifests. This templating method to generate manifests is simpler and more readable than other templating engines. Notice that there is indentation before each line of the template. Anemos strips the common indentation from the templates, so you can indent them as much as you want. Let's build our project with the Anemos build command. When we run the build command, Anemos generates the manifests and writes them in an output directory beside our index.js file. If we look at the generated pod manifest, it contains the variable values as expected. Anemos also allows you to use JavaScript objects to define your manifests. This feature brings type safety, better IntelliSense support, and enables a better development experience overall. Let's add a service definition using this method. But before that, let's add a package to get type definitions for Kubernetes objects. Anemos uses the JavaScript package management system, so you can add packages from the npm registry. In this case, we will add the Kubernetes models library using the Anemos package add command. Let's import the package we just installed and define a service object using the types provided by the package. You can use IntelliSense to see available objects and fields, and if you use TypeScript, you can get compiler errors when you use an incorrect object model. Let's build our project again, but before that, since running the build command manually slows us down, we will define a VS Code shortcut. Open up the keybindings.json file by pressing Ctrl-Shift-P and searching for keyboard.json. Then paste this snippet that you can find in the Anemos documentation. This is a one-time process, so you don't need to do this for every project. Now, let's press Ctrl F5 to build our project and see that our new service definition manifest is written to the output directory. Being able to add documents to the builder is useful, but you probably won't define all your manifests in a single file. Instead, you will likely have some packages that you can reuse across different projects. Anemos packages are just like any other JavaScript package, so we can add and use them the same way as we use the Kubernetes models package. Let's add an example package called Anemos Hello World to our project using the Anemos package add command. After the package is added, we can import it and start using its features. When we build our project with Ctrl F5, the manifests generated by the package are written into the output directory. Writing the outputs into the project directory allows us to track them using source control. This is a powerful feature that acts as a unit test for our project. To see it in action, let's initialize a Git repository in our project directory and stage everything to track the effects of the changes we will make in a moment. The API of the Hello World package we just installed allows us to specify some options. Using IntelliSense, we can see that it accepts an option for autoscaling, and we want to enable autoscaling for our Hello World application. So, we pass an option for autoscaling and set the minimum replicas to 2 and the maximum replicas to 4. When we build our project, we see that a horizontal pod autoscaler manifest is added as expected. However, there is also a change in the deployment manifest that we didn't expect. The replicas field was removed from the deployment. Using source control, we code the unexpected changes immediately after modifying the options. Okay, we code the unexpected changes, but what can we do about them? We want to use the HBA from the package, but we don't want to remove the replicas field from the deployment. Anemos provides a powerful feature that allows us to modify the generated manifests. When builder.build is called, Anemos runs some actions in a predefined order. The builder.addDocument function, for example, adds an action to the builder that runs during the generate resources step. The Hello World package also adds its manifests during the same step. You can define your own custom steps, but in this case, Anemos has a built-in step called modify that runs after the generate resources step. Let's add an action that runs during the modify step and sets our deployment's replicas field. If we build our project again, we can see that the unexpected change is reverted. In this demo, we have seen some basic features of Anemos. Anemos has many features to make Kubernetes manifest management easy, flexible, and scalable. To learn more about Anemos, visit our documentation. And since Anemos is an open source project, you can contribute to it on GitHub. Thanks.